Welcome guys to another little video, and today's little video is going to be on player movement because I decided to rewrite a little bit of the script so that we can get some cool stuff like, we've got our weapon changing and stuff, we get our zoom that's a little better than what it was before. Well, it seems to be anyway, let's say. But now we're going to be able to duck, get lower and above and beyond, just that whole thing. Now I probably could make this a little lower for ducking, right? And we gotta go on our main here. And it's 32. I called it sneaking, but it could be anything like that. Boom. Let's mute that because that's really loud. And we're really small and slow. Or we can get back to walking. This is walking. And then my favorite is always a boing, which is running. And I rewrote it so that you could change the fading in and out. When we go to walking to running, it can be more gradual, or it could be like instantaneous if you really wanted to. Okay? And that's the whole point of that, is we can go low, sneak around, or we can go back up to walking around like fine, or running. As you can see, we go a lot faster. This becomes more apparent if I just put a lot more speed into it, like do walking, and then and I went off the edge. Okay, well, regardless, we get the idea here. Okay, now basically what we're doing is we're taking a script in our soldier and we're giving it specific states. Now this means rewriting it just a little. Okay, height is how high our controller needs to be. Okay, speed is how fast we go, and fade is the bigger the number, the longer it takes to go from that transition, from your last transition to your next one. And that is for fading the speed. Okay? Run, it's bigger because it needs to be more instantaneous. And then sneaking goes bigger as well. So walking is kind of lower because, well, I wanted it to be a little bit, it take a little bit longer, because I was thinking about it when I'm like sneaking around or ducking, pretty much the same values will be fed into the system, right? Well, the thing about it is, if I do that, I need it to be kind of sluggish if I'm going from like sneaking to walking, okay? Or sneaking to running and vice versa. Going from running from really, really fast for us takes a little bit. So we have to, have a little bit of fade. Now, the way I do this isn't with lerp, because I kind of have a problem with lerp, and I'll explain it in a second. And it's mostly to do with how it interpolates, okay? And that's kind of like a touchy subject somewhat for certain things, and other things it works pretty alright. So our controller class is still sealed. I have it in a small abstract class that's called character class, which, you know, you can have mono behavior here. It doesn't matter. The only reason I put this here is to make sure that I know this is a character class. It all deals with the character. Okay? We got our slot, which I shouldn't have to explain to you guys, but this, why do I have this here? I don't think this actually should be here. I think this actually is not referenced in the script at all. Why do I have melee here? Find all references. It shouldn't be in here. It should be in weapon manager, right? I interface soldier manager weapon. Yeah, this is actually doing the wrong thing. This actually shouldn't be in here. Bloop. Goodbye. Hasta lita. The weapon transform has to be in here because of referencing to the mouse look, I believe. Right? Yeah. It initializes our mouse look. Right? Yeah. Or good old mousy looky. We don't actually have to have it initialized, but it's forcing a sanity check for us. And besides, our mouse look doesn't have a update, so we need this to be referenced like this anyway. We could put its own little update and things, but then, you know, it's kind of a waste to have another update when we could just feed it off this script. And besides, this actually needs to know that information anyway. Oh, and to the mouse look itself, which goes into an interface of mouse behavior, the look rotation and things needs to stop when we want it to. But that's a whole nother subject. We have a serializable field is grounded that we can reference in other stuff. We have a serializable field that also has a range, but we're passing float and jump speed in here. Okay, this is all one thing. It's just got multiple attributes. Okay, but down here we've got these private fields here. These are considered private because of there's no public thing, or you can still forcefully make it private or protected. Okay, but it really doesn't matter which way you do it, as long as I just don't think it should be public, because no script should reference this speed directly. Okay, it should only be this one. Now you're like, speed and then last speed. Well, why do we have this? Well, speed is a constant variable that always gets fed into our controller class. Okay, we always feed in directional times by speed. Okay, so it always gets fed in there. And if we want to lerp to a value, then we need a this is where we are, this is where we want to be all the time. And then I also have a variable for height. Now, these values are basically reference values for things this is speed that we're at, this is where we need to be, and this is our height. If you think about lerp, okay, current and then where we want to go to. Well, this also works really good for a bool check, and that's what we do in our set state. No, it would be called character adjuster. Yeah, character adjuster. Character adjuster gets updated every single frame. Okay, but see how I got the speed and last speed? Well, my setting a state, I need to compare these so that I can lerp them. Lerps like this is a function call up to the Unity API, okay, which every single frame is kind of a waste of performance, okay. So I know this seems like a small thing, but we're lerping a lot of things. We're lerping our weapons, we're lerping our rotation, the weapon position, then we have a sway, okay, that's a lerp, that's basically another lerp. So anytime that we can cut some of these lerps out is kind of good, because if it's only comparing two little values, it's a lot easier on the CPU to go, hey, are these values the same? Boom, no, yes. So it's basically like a function that only happens every, 30 frames or so, or when it changes. So we need that cutoff point. The problem with lerp is vector the problem with lerp with vector 2 or vector 3 lerp is it can't be compared because of it never truly gets to the end values from 0 to 1, it will return point 9999999 F and never get to 1. So bool checks return false Wait. Have one of the dull moments. So bool checks return false forever. And return runs lerp forever. I don't know how else to explain that. And I'll move toward will not. Move toward will reach end and allow a check bool to run the right way. I know it's a cop-out for wording and everything else, but whatever. So these bool checks right here, like speed does not equal last speed, this will return false, so this will run, okay? But if it's equal last speed, then it will skip over this. Okay, this function call will never run. In comparing two values, very, very easy on CPU wise. So we save there. Okay, and then we do the same thing with our controller height. Okay, because I do not want to restructure the controller height every single frame. If you look at the profiler, when controlling the height, you can actually pretty much see the frame rate kind of move around. It's kind of heavy, because what Unity does is it's got to recalculate the entire bounds, the mesh that it uses. Very, very performant heavy. If anytime you're doing a mesh in real time, you're moving it around, very, very heavy. A lot of times those calculations and some other things like that will actually be ran on a separate thread just for that. And in Unity, if you try to use another thread, then you don't have an access to Unity's main thread, and you got to dance around that whole thing, and that is just awful. So I do not want to touch the threading stuff. Threading is not very easy. Take my word for it, it sucks. So down to that. So these floats are always here, so we can do constants and stuff, but it doesn't explain why yet. Okay, we're using this to constantly do that. But if you look at our current state, and we have a script that's called state, right? Let's take a look at this state script, okay? And all it is a serializable class that is inside of our class itself. So no other class has access to this. This is completely like contained inside the script. So if anybody else tries to go looking for a state class, it will not work for them. Okay? Because it's not publicly accessible. unless we made it publicly accessible, which is kind of not useful for us. Okay? So we got a height, a speed, and then my fade value, which is kind of a crummy name for us, I admit, but that's all that's for. And it's all the same. Okay, notice how these are all the same. That's very important. Okay, very, very important. And we actually have to... I need to make a small change. Set state. Okay, and this needs to go to walk. Because when I start, I need to be in the walking state. It just makes more sense, right? Just makes more sense to me, too. Okay, so we got walking, running, and sneaking, which actually could be called ducking or anything else, because they're all the same. But in the update, we are no longer going with some of the checks here. We still need the controller data, but what we don't need is some of the other things that used to exist. We still use the fall speed. We still use the mouse look rotation. And that's the reason why we need the weapon transform. Okay? Which actually probably should be called the camera transform. But notice how we got all these checks for buttons, and they're all input get button down. Now this is very, very important, because when we're setting a state, we don't want the every single frame be setting the state. That would be like sitting there calling update when you don't need it. It's useless. So get button down only returns once. If you sit there and hit the number 1 key, okay, for input get button down, it will return true in a single frame, and it will never return true until you let up the button and then push it down again, which is basically a one-time event, which is really nice, because if we're hitting the shift key, which is our run key for me, and we're setting a state, then it only happens once, and we're doing set state to run. And then guess what? When get button up happens, which is the up position of the key, we return to the walking state. But I also used this sneak thing, okay, which is my letter key C. Now, sneaking is a little different because it doesn't really return. We don't do an input get button up for it. Because if we want to sneak around permanently forever or duck, I don't want to sit there and hold the C key the whole time. That would kind of suck. I'm not going to lie. It would suck. Alright? If I want to push the button again and get out of sneak, I can't. Because I've got logic elsewhere. But that's a whole different thing. So we got the character adjust, which we went through. Now let's look at the set state. It's a private void, which takes a state, and we compare 2 states, which is very, very easy. Very, very. If the current state equals current, the state that we pass in equals the current state, we set all the information to the walking state. We don't care, we just go back to the walking. So it's kind of like our default behavior. Run doesn't matter. When we let up the run key, it will automatically go to walk. If we hit C twice, it'll automatically go to walk. So anytime that I let go of a button or push a different button, kind of the default behavior, if it freaks out and doesn't know what to do, is going to be the walking state. The running part, well, we're all the time holding run, but if we push the C key while we're hitting run, it will go straight into the sneaking thing. So it's kind of the last key that you hit, that's what state you're going to be in. There's no bunch of crazy if statements or anything else. Okay? But if S does not equal the current state, then we accept it. We accept everything that it's doing. So it gives us the simple functionality of, hey, sneaking, you're going to sneak. But if you hit shift, you're going to go to walk or run or the next thing on it. So holding our sneak key and hitting shift will take us into running, which is kind of fine. But then if we let go, it doesn't care about the previous key. It just goes directly to the one that you just fired off, which could be the up key on shift or the C key or any of the other states that you're going to program in your game, because this is easy. This is easy checks right here. We can compare a whole crap load of buttons, and it's not going to be heavy on your computer. Unless you're using input get keys, which is taking a key code, that's a little bit heavier. I'll admit, doing those kind of checks, you actually see it in the profiler. That's kind of its own call. I mean, like big time. So we set last speed to s.speed, height to the height, and smoothing to the fade, and current state, we change the current state to that. Now the reason why I do that is for this compare right here. So, if we hit, the sneak key or ducking or whatever you call it, and it fires it off one time, if it's the same thing, then we just go to walking, because that's kind of the behavior that I would like to go to. This compare is really simple too, which actually in one way I think I should have it the other way around. So when the CPU goes to this, it will compare it here, but it will still ignore this, which this is still fast, but it's kind of like an order of operation thing, and that's all it is. If you wanted to add another state, just add another state. I don't want to make it public. Serializable field, you go to state, and you're going to go hi buddy, okay? And then you go down here, and guess what? You're going to go down here, and you're going to go else if input dot get button down. You're going to type in some kind of thing, and set state, and we're going to go hi buddy. Boom, there you go. Which you'll have to fill in this key thing, and go into the input manager in the Unity and stuff. But that's kind of how you would add a state. But in this tutorial, we're doing a soldier thing, so it doesn't really make sense to have anything other than running, walking, and sneaking. Okay, doesn't make sense for us now. But, and this is the big thing, when we get to our medic class or something like that, we'll be able to cut a lot of this code out, because our medic class shouldn't be sneaking around. They should only have what, maybe walk or run, and that's about it. Or maybe in your game, the medic class can only walk. Okay, they're slow, but they can heal a lot. You know, they're healers. So ultimately, you know, you get your other classes in there, and you're like, well, I want him to be able to heal stuff, but I want him to, you know, go, hey, let's make the healing class really, really slow, but he can heal like his full heals every 3 seconds or so. So the other guys around him can get healed up really, really quick and go back in there. But the other guys are heavily armored, so they can take more of a beating, right? And that's how you can, you know, do that whole resistance and balance stuff. So I think this is a little bit better in everything. So appreciate the assist and the view. And this is War. I think we're over and out. And thanks for watching. Like, hit, subscribe, and peace, guys. Take care.